So 2014 paper 2 question 9. So at an activity centre, a zip line is B to D, runs between two vertical poles A, B and C, D. On level ground as shown, the point E is on the ground directly below the zip line. So A to E is 12, B to E is 14, and C to D is 1.95 and E to C is 10. So first thing you should do is just check they're all in the right unit and there. So find the distance from E to D. So E to D is here. And you can see that this is actually a right angle triangle. So they're asking you to find E to D, which is here. So for a right angle triangle, you can use SOHCAHTOA or Pythagoras. I'm going to use Pythagoras here because I have two known sides already. So Pythagoras' theorem is equal to C squared is equal to A squared plus B squared. So you know that C squared is always across from the right angle. So that's what you're looking for. So C squared is replaced by X squared. A is just one of the shorter sides. So I can say 10 squared plus 1.95 squared because that's B, that's another shorter side. So all I need to do now is put 10 squared plus 1.95 to be squared into my calculator. I get 103.8025. I want to find what X is, so I just square root that. And I want it to one decimal place, so that's 10.2. And that's in meters. For part 2, they're asking me to find the length of the angle AEB. So AEB, so I'm trying to find this angle here. So correct the nearest degree. So again, it's a right angle triangle. So this I'm looking for an angle. You can't find an angle using Pythagoras. But with a right angle triangle, you can use SOHCAHTOA. So I label the sides that are given to me. So this is the angle here, so this must be the adjacent, and this is across from the right angle, so this must be the hypotenuse. So A and H must have to use cos. So cos of the angle is equal to the adjacent over the hypotenuse. So that's where K comes from. So then I just replace the information that I have. So cos of the angle is equal to A, which is 12 over 14. So I know when I'm trying to find an angle, I do cos of minus 1. So I'm going to do shift cos. I'm going to do 12 over 14, close the bracket, and I get 31. So they wanted the nearest degrees, so that's 31 degrees. Because it's 0.0, so it just stays at 31. For part B then, so find the angle of DEB. So find DEB. So you know that this one here now is 31. And they're asking me to find DEB. So they're asking me to find this one here. Given that CED is 11. So CED is 11. Okay, so I've got angles on a straight line. So I know they add up to 180. So all I can do here is 180 minus 11 and minus the 31 that I just found. So 180 minus 11 minus 31, and that gives me 138 degrees. For part 2 then, so hence or otherwise find the distance of D to B, give your answer correct to one decimal place. So D to B is here. So we've used X, Y, right, let's call this Z. So I know that this is 138. And I know that X is 10.2. So what I can do here is, it's a non-right angle triangle, so I can use sine or cosine rule. So I'm looking again at sine rule or cosine rule. I know that this has to do with opposites, and I know that this has to do with side angle side or side side side. So, do I have all three sides? No, that's what I'm looking for. Do I have a side, an angle and a side? Yes, I do. So, cosine rule is what you're going to use. So, the cosine rule is A squared is equal to B squared plus C squared minus 2BC cos of A. So A is always across from the angle, so that is what I'm calling Z. Z for zip line. So Z squared is equal to B squared. I'm just going to use this as B, so 14 squared. Plus C, I'm just going to use that 10.2. Minus 2 times 14 by 10.2. Cos of the angle across from Z, and that is 138. So I can put all that into my calculator. So 14 plus 10.2 squared, minus 2 times 14 by 10.2, and then I have cos of 138, close bracket, and that's 512.2821622. So I'm trying to find Z, so just square root that. And I want it to one decimal place. So that is 22.6. So 22.6, and this is in meters.